All right. Hello, everyone. Thank you for joining DataCon LA. Welcome to Human Capital Growth Analytics. My name is Hestia, your host, and your co-host today is Apurva. Please be mindful of our COVID regulation. Keep your mask on. Also, silence your phone during session. Don't hesitate to raise your hand if you have any questions. This session is currently streaming via Zoom and will be recorded. It will be available online in a few weeks. Today, we have our guest. Her name is Aboli. Aboli Khairnar. I'm sorry. And she is data scientist on Venture Innovation Studio team, where she helps leverage the power of data science and machine learning to maximize their impact. She's passionate about using data for social good, and she works as a data analyst, analyzing and predicting flood frequency risk for rural catchment. So without further ado, I'll hand this over to the speaker. Thanks for being here.
Hello. Yeah. Thanks, Hestia, for the introduction. Hi, everyone. I'm Aboli. I'm data scientist on Citi's Venture Innovation team. Thank you so much for joining. Let's get started with the presentation. So as you can see, the title of the presentation is Human Capital Growth Analytics. And before we start, okay, I'm not able to change the slide. Yeah, I can use the down. Yes, yeah, thanks. Yeah. So before we start with the actual work, I'll start with the introduction and more about what is intellectual and knowledge capital. So basically, these are the intangible assets of an organization that help them achieve their business goals. And it can include like employee skill set, their knowledge, or the company's special algorithm models, data information about processes, all that, and also like patents and like regulatory licenses. So these are like intangible assets. So what are intangible assets? Basically, they are hard to measure. So traditionally, if we have to see how do we compare a financial performance of a firm, so we look at the tangible assets. The tangible features can be anything like total revenue growth rate or the EBITDA, which is like the profitability measures. But often we pay less attention to the intangible assets. So does that mean that these are the less important features? Definitely not. So in this work, we will actually take a deeper dive into these intangible assets and more specifically the human capital. And we'll see how we can use this to actually drive the workforce analytics decisions. And I have highlighted one news article in this session, and this is from the verified market research. It shows there is like this recent interest into the human capital management and investment. So you can see they say that by 2030, the market size will be worth around like $41.43 billion with the growth rate of 7.49%. So definitely there is like increased awareness about like these intangible assets. Yeah. So here we can see that intellectual capital is a very broader and general term, but if we have to divide it into like three different parts, it will be like human capital, the relational capital, and the structural capital. For the scope of this presentation, I'm only going to focus on the human capital and not actually cover the relational and like structural capital, because again, like they are very difficult to measure. For the human capital, we can at least get some data. And I'll talk about the data more in detail in the later slides. So human capital, these are basically the contribution made to an organization by their employee. So basically employees' knowledge and their skill sets that organization use to drive their business outcomes. So these are basically come under the human capital category. So what do they provide to an organization? Definitely a competitive advantage, because a company is as good as its employees. And we can use this insight in our work. And our hypothesis is that quality organizations are the one who knows how to utilize their human capital and actually use it in an optimum way, so that can lead to the financial returns in the future. So before we start with the methodology and like the technical details, I will just summarize what we learned so far. So we learned about the importance of analyzing these intangible assets. We learned about what is human capital and how we can use it. Why there is need to actually use this human capital into our studies. But if you look into the literature, there is like close to none available for organizational level human capital analytics. If you look at the country level, there is a lot of literature for the human capital analytics, but at the organization, close to none. So in this presentation, we are going to dive deeper into the company level human capital analytics and see how companies can take like data-driven, more informed workforce analytics decisions. So let's start with the technical part. I'll start with like assumptions. So basically every study has some kind of assumptions to simplify and apply the machine learning or in general, like any kind of algorithm. So there are like 4 key assumptions. The first one is like data accuracy. So basically we get our data from different vendors for the employee level data and financial data. So we assume that the data that they provide us is accurately represent the ground truth. The second one is like there is no spillover effects for R&D because companies spend a lot of money into R&D and getting that innovation out into the door. But like other companies which are like competitors can just take the advantage of that R&D, their innovation without like spending that much money and efforts. But for our scope of this presentation, I'm assuming that there are no spillover effects for R&D. And the third assumption is more about the constant workplace productivity. So basically, what does this mean? Employees' productivity gets affected due to a number of factors. It can be like work-life balance or the organizational culture, etc. For our analysis, we are saying that all these factors that affects employees' productivity are constant across all the organizations that we have in our data set. And the last but not least, we assume that the data is missing at random. So this is necessary to apply certain imputation algorithm, machine learning algorithm. And if we don't have this assumption, then our data that is imputed can be highly biased and can lead to inaccurate results. So this is our data science workflow. It is divided into 3 parts. First is like data pre-processing. Second is data modeling. And third is like making recommendations. So in the data pre-processing, what do we do is like, we get the financial data, then we also get the employee level data. We try to like clean this data, merge it together. And as you know, data scientists spend almost around 80% of the time in like data cleaning. So we do spend a lot of time in this first chunk. It is important. And once our data is ready to feed into the model, we move on to the next part, which is like modeling. So as you can see, I'm highlighting the classification model using random forest. So this is something that we do using H2O auto ML models, and it can train the model really fast, and it can try like hundreds and thousands of models, keep track of different models. So that is very handy. So I will definitely suggest like get hands-on experience with the H2O auto ML. It's a package publicly available. And the last part is like a recommendation. So where there are like 2 primary goals. The first is like create this index, which we call as human capital index. Not only summarizes companies' human capital, but also links to the financial performance. So that there is like incentive for organization to use this index, and as well as it's helpful for like employees. They should know like what the skill they should be looking for, and it creates more transparent market. And the second is like customize human capital investment. I'll talk more about this in the later part of the presentation, but basically what we are trying to answer here is if a company needs to change their workforce allocations, what are the employees they should be hiring? Because it won't be same for every organization. Every organization has different needs. So what are the skill set they should be focusing on? What are the important human capital factors for their organization? And what are the factors where they need some little help? maybe they need to train their employees on hire new employees in that domain. So let's talk about the data. So as I said, we collect the data from two different vendors. First is like employee data, which we get from Revalue Labs. They provide us the data on like employee salary, attrition, gender, race, job titles, skills, etc. So how do they get this data? So company don't provide this data. So they collect it from LinkedIn job profiles. So they scrape this data for all the firms, public firms across US, and then they structure it in a way that is more handy and ready to use, and they give that data to us. And the second data is like financial data that we collect from Capital IQ, S&P's financial database. And it has data on like revenue, profitability, return on equity, and stock price, etc. I'm just highlighting few, but they have like a lot of data. And again, like data is not clean. It's not always structured, so we have to clean it. The major finding that we saw that most of the companies don't report their R&D, so we had to include this data. And around like 16% of the R&D data that we have is filled in using like various machine learning including techniques. Okay, so now we are talking more about the model. You can see I have highlighted like few important parameters that goes into our model. Again, this is a classification model, more specifically like binary classification. So it helps us to identify whether the firm is high growth or low growth. So there should be like some threshold that goes into the model which tells the model whether the firm is high growth or low growth. These are basically the labels that we provide to our model. So for our presentation, we are assuming that a firm which has like total revenue growth rate higher than like certain threshold, which is like 2.7 for us for this model, are the high growth firm. Otherwise, they are the low growth firm. So that is something our model will use to train the entire data set on the human capital features. So this is just a target variable that I talked about, but we also provide like different human capital factors that goes as input into the model. And the first is like R&D expense. So this is not just the R&D, it's R&D expense or as of total revenue for a company, because R&D can be different for multiple firms, and for some firms it can be really high, and for some firms it can be really low. So we found that R&D as of total revenue makes more sense into the model. We have second feature which is employees in the technical roles. So that is so we had this list of these roles which are mostly the science, engineering, technical, math roles, and we tried to use this role and saw like how much percentage of employee each organization has in these particular roles, and we name this feature as employees in the technical roles. And the third one is like employee across top skill clusters. So this is the data, as I said, we get from Revalue Labs, and they have like different skill clusters. So I'm just highlighting few, but there are many clusters which vary across like finance, marketing, like science, engineering, like technical, more software development, data, etc. And we have around like 15 skill clusters that goes into the model. And we control for like different factors such as company sector, whether it's financial sector, healthcare sector, or IT sector. So we try to control for that. We also control for like firm size, whether it's a big firm or not, because if a firm is big, it tends to have actually lower total revenue growth rate. So we thought like it's better idea to just like control for that, so our results are not biased. And the last but not the least, we also control for location, because the total revenue growth rate for firms from the western side are higher. So just because our model is not biased, because we are not providing this feature, we try to have that in our model as well. So this is about the feature that goes into the model. Now we'll talk about the results, the key results that we have. So the graph that you see on this slide is called PDP plot. So what are these PDP plot? These are basically the partial dependence plot. Now, why do we need it? Because the model that we are using is a tree-based model. So it's mostly the black box model. So does that mean that we don't get any insight into the model that what's happening? So no. So there are these PDB plots that we can use. It will tell us how a model is taking the decision that it takes. And this is again comes really handy when you have to explain this to a key stakeholder, because you can't just like use the technical jargon, because you have to simplify it in a way that every audience can understand it. Now you can see this plot on x-axis. We have percentage of workforce for data analytics, engineering management, software development, and percentage of R&D spend for the R&D. And on y-axis, we have probability of firm being a high growth firm. So what this plot tells us? So it tells us how each of these human capital factor affects the average prediction of a firm's performance. So it gives us the insight into our model. And as you can see, the relationship is definitely not linear, it's non-linear. And interestingly, for data analytics, it actually follows the law of margining, like diminishing margin utility. You can see the probability of firm being a high growth increases, and then it reaches a certain level and it decreases. And for engineering management, software development, and R&D, there is a consistent increase, but again, like non-linear. So that was about our model and giving more insight into how our model is driving the decisions. This is a sample output of the Human Capital Growth Index that I talked in the earlier step. And you can see I have highlighted like few companies. I have changed their names here. And you can see we have like different human capital factors. Again, I'm just highlighting few of them because we can't put everything in this. Like I just have highlighted few important ones. We have percentage R&D, percentage tech roles, percentage employee by skill cluster, sector, and state. And this one, this column particular, you can see it shows the human capital index. If you look at these arrows, it tells us whether the firm was high growth firm or low growth firm. So if the arrow is green, it was high growth firm. If the arrow was red, it was a low growth firm. And you can see that the top rated firms for this particular output, most of them belongs to IT sector and located in California. So the importance of the control is very, you can see the importance here because it clearly pointed out that California and being in IT sector like leads to more total revenue growth rate. And if you look at the firms which are like have lowest, which have low human capital index are mostly the firms belonging to the like consumer discretionary and like financial sector, and they are not located into the western part of the US. And if you look at the topmost company, it's again IT and California. It has the perfect score of human capital index 100. I can't say which company is this, but yeah. And moving on to the next slide. So as we can see that I have plotted the scatter plot here. It shows on x-axis we have total revenue growth rate and y-axis we have human capital index. So the total revenue growth rate is not something that we provided our model, but we just want to see whether it learned that correlation, because scatter plots can come really handy when you are explaining a model or like the results. So the correlation between the human capital index and the total revenue growth rate is around 54%. So it's not that high, but it's not also low. So our model did like pretty good job, and it's also like initial level model. We are trying like advanced model every like single day, and like they are giving like better results than this. Now we'll move on to the next part of our recommendation, which was the customized human capital plan. And I have shown like two fictional firms here, Apexify Labs and like Bottom Up Solution. So Apexify Lab is a high growth firm. It has like total revenue growth rate of 12%, and Bottom Up Solution is a low growth firm which have like total revenue growth rate of minus 5.5%. So on the right side, you can see I have shown the contribution of these human capital factors toward the total revenue growth rate. The color for Bottom Up Solution, which is like low growth firm, is dark blue. Color for Apexify Labs, which is high growth firm, is light blue. And you can see the bar plot here. if you look at the contribution of each of these human capital factors for bottom-up solutions, it's consistently lower compared to Apexify labs. And the difference is pretty much significant for R&D and percentage of employee across like technical roles, software engineering, data and engineering management skills. So as per our hypothesis that there is scope to improve bottom solutions revenue growth rate by increasing the contribution of these particular factors. So we can actually target these factors and actually hire more employees in this particular skill cluster, or like train their existing employees in this cluster so that they can boost their total revenue growth rate. Now, how do we do that? So this is an MVP app that we created, and it basically shows the human capital factors, their existing allocations and new allocations for bottom-up solutions. And you can try actually different new allocations for this particular firm. And you can actually run this app and it will show whether with this new allocation, this firm could have a high growth firm or not. So this is just a sample output of that. I will highlight one of the case that works for bottom-up solution in the next slide. So this is like one combination of multiple combination that is possible with this app for bottom-up solution. And one way they can increase their total revenue growth rate from minus 5.5% to at least 2.5%, which is our median threshold for the model, is by making few changes related to their human capital. They can increase their percentage employees in the SQL, Linux software development and Java, C++ skills by 4% and increasing their percentage R&D by at least 5%. So if they do that, they can increase their total revenue growth rate. They can boost their growth rate. Again, we are focusing only on one aspect of improving the productivity, which is like hire for additional employee. But this can also be done by training their existing employees in a way that is more transparent and more profitable for the organization as well as the employees. So next steps. As we move ahead with the analysis, we are understanding that we need like more, we need to try more financial metrics such as like EBITDA, which is like profitability measure, and total revenue. Try like more models, not just like classification, but also look into like different machine learning algorithm instead of like tree-based model. So tree-based model are really powerful, but can we like use a regression model, which is more simpler? It might not be like fully accurate, but it will actually simplify the analysis. So we are trying different models, trying to add more data into our analysis. And also we are trying to improve the interpretability of this human capital index. And we are also looking data on like startups. Right now we just have like data on the public firms in the US, but we want to add more data like on startups. Also, last but not the least, we have to look into the causality. So all the analysis we did right now is based on correlations. It doesn't reflect the causality. So what is causality is basically is hiring his employee will increase the total revenue growth rate for a firm or not? Is this something that leads to the increase in the boost in the total revenue growth rate? So that is something will be covered by the causality, and we are looking more into that now. And yeah, that will be the next step. So that concludes the presentation. Happy to take any questions you might have. Yeah, there are questions. Yeah. How did we?
How did you compute the data?
Impute the data, yeah. That's.
So I'm curious to know, how did your team compute the
Yes.
data?
Yes, definitely. That's a great question. So imputing data can lead to like sometimes misleading results, but we had to be very careful on how much amount of data we are imputing. So we are just imputing around like 16% of R&D data, which is not much. And also we are using like machine learning algorithms such as mice, a multiple imputation method to actually fill that data. And we not only just like fill the data, we also try to like test it. So every time we input the data, we also have the validation set and the test set. So we always check the performance of that inputted data for that. And we also check for few firms, at least for Citi, we had like internal data, and when like Citi also doesn't report the R&D data, but we had the internal information. So we were able to verify that inputted data with actually real world data. So that's how we did that. Does that answer your question?
Yeah.
Mhm.
I got a question.
Mhm.
So for your model, so I believe you said you use skill clusters, right?
Yeah.
Instead of using like each individual one, it's like pretty excessive amount of columns.
Yeah.
So what kind of data type was that? Was that like a 1 to 10 kind of situation, or?
Yeah, so we have total 15 skill clusters, and we get this data from Revelio Labs. It's collected from the LinkedIn job profile. So we don't have like data on every single employee, but we try to cluster it for different skills for different organizations, because if we put the data for every single employee, like it will be like huge amount of data and like not that useful. So we had to feature engineer this particular feature, and like there were like few clusters that were already created and provided by Revelio, but we also like had to go through each single cluster and actually like combine it into combining it to make it more sense, like make more sense from it. So in the end, we are left with like 15 skill clusters across like data, marketing, finance, like engineering, etc.
Okay, I see.
Mhm.
Because I think if anything, 'cause I know one of your slides, you had it where you can see like, oh, if we increased it, software development by like, to 40%, that it'd be, it would lead to more chances of high growth, right? But
Yes.
like, is that still a skill cluster, or is that not like its own?
Yes. So
Okay.
that is for the skill cluster. So if you get one more employee of that skill or train your employee with that particular skill, so that will reflect in that particular skill cluster feature. Yeah.
This is an app that you guys created for Citi or something that you guys.
Which one?
You said that it was an app.
So this is for the fictional firm. We call it bottom-up solutions, but this can be done for any other company. Yeah, it can be fine-tuned in a way, like it can be used for any other company.
How do you evaluate the reliability of like whatever solutions being provided? What is the reliability
Yes.
that is going to work for that?
Yeah, definitely. I think that's a great question. And that's why like we are not in a hurry to implement this model and actually drive like the workforce analytics or even the hiring decisions as of now, because we have to look into the causality. With the causality, we'll be able to answer, okay, hiring this particular employees will actually lead to the increase in the total revenue growth rate. And the analysis that we have is for 2020. So that is something we can actually go back and check with the 2020's data. We haven't done that yet, but that's how we are going to actually double check the results. Mhm.
During that check, are you all going to take into account maybe the skill sets of pre-pandemic and also
Absolutely.
post-pandemic? Because
Yes.
like,
I
it
think
may not be
that's
a factor, but that's something you have to validate if it becomes a factor, right?
yes, that's I think the great observation, because we definitely want to separate the pre-pandemic and post-pandemic data. There has been like complete like skill transformation that people went through in this pandemic. So definitely that will be like one more control. And even we want to like separate these particular uh, events into different like studies into the causality model. So yeah.
Will this be able to be used within any industry? Like, I mean, I'm thinking like even industries where you've got unions, there's strikes and things like factors like that that have to be considered.
So we are not sure how we are going to like account for that as of now. Like we have the industry features, so this should be we should be able to use this for any firms in like any industry. Is it like accurate? We don't know it like we have to do the causality analysis, but yeah, that is something can be done at this stage just based on the correlations. Awesome. Do you have a question? Yeah.
Oh, yeah. So do you think that this model can be used similarly for like how to evaluate a high growth employee versus a low growth employee?
Yeah, definitely. So there is one more feature that I didn't show. It was like productivity per employee. So that was something we were adding in the beginning, but it didn't have like enough observation, so we had to remove it. As of now, we won't be able to identify that, and that's the reason we had that assumption. So I haven't shown that here, but yeah, so we assume that the productivity across all the employees is the same, because we don't have the data on the internal like performance review. Like we don't know how to differentiate a high performing like employee from like low performing.
Yeah, let's just say coaching conversations.
Yeah, so yeah, exactly. So if we can get that data, that would be like awesome, but right now we don't have it.
Thank you.
Thanks. Awesome. I think there are no more questions. We can like conclude the presentation. So feel free to reach out to me via email or connect me over LinkedIn. And I hope you enjoy the rest of your conference. Thank you.
Thank you, Aboli, for your presentation, and the attendees for questions, interactions during sessions. You can contact speaker directly if there are any further questions. Please provide your feedback on the form. Thank you, guys. Have a good day.